the guest teachers don't have like the same access. Well, I don't even know. Mr. Manning might, because he's a permanent guest teacher. He's like always, and maybe not this year, because actually this year he's going to go to Europe. But all because I'm not here to check in on what you're doing on Securely or whatever, Dino, whatever you guys know it as, doesn't mean that no one is. So remember,
I can still get in.
the other teachers are here. So a lot of times, like, when I'm not here, Pettigrew might watch my class. Or Hassanin, if she's not teaching, right? She'll just have it open on her screen, just checking what people are doing. Like, I'm trying to be honest with you guys so you don't make your life tougher. What we're getting to is the point of we'll just permanently block YouTube. Or permanently block whatever. But not for everyone. For just you. Because if you can't handle it, then you'll have to get special permission to be able to, like, when you're mastered, get on YouTube and watch your own music, and then we'd have to unblock it. Like, that all feels really annoying to you and to us. The way to avoid that is just when we're doing classwork on Chromebooks, you just do what you're supposed to do first. Only. Not 8 different tabs open at once. You just do what you're supposed to do. And then, when you're done with that, you can do whatever else you want. Within reason, right? School appropriate. If you have work to do, do work. But if you're totally mastered, we want to be able to give you the freedom. We were talking about games this morning. Like, we had a little team meeting. It wasn't all of us, but we just ended up in the same room. We were talking about, yeah, if they're mastered, I don't care if they play video games. But don't make us restrict you more, right? So all that to say, with our guest teacher, Mr. Manning, here tomorrow, please don't try to be sneaky. Just do what you're supposed to do, so we don't have to like start blocking more things and making more rules. Cool? Sweet. So let's do that right now. Let's practice that by just working on the Desmos. Once we all get past a certain point of the Desmos, I'll probably pull us together to talk about it, and we'll keep going. If we get totally done, we'll probably spend some time working on Khan. Okay, is anyone else freaked out by the fact that there's just a floating head right there? Right here. It's like above my loader Chrome. It's just a floating head. Well, there was a hand waving for a second. It's just a floating head. You guys aren't freaked out by this? Does anyone get the joke? Jimmy's wearing camouflage. Camouflage is supposed to camouflage you, which means like blend into your surroundings. So if it really worked, all we would see is his head floating there. It's just a silly joke about camouflage. All right, Robot Factory. Robot Factory. Alright, refocus. How many people laughing like those weird Halloween decorations? So stop. That's a setting that you can.
I hit myself. Beckelheimer, Amara Fawley, and Cam Swisher, please report to the Perry main office.
Let's get this question. What are things you notice about
Amara
the
Fawley and Cam Swisher to the Perry main office, please. Thank you.
I want to challenge us to work for 4 minutes independently without making noises or talking. 4 minutes. I bet we can do it. guys don't feel, and I don't always do this because I want you to be confident with your answers. But like, I'm going to anonymize, especially because I normally record your guys' class, and I don't want to put your names out there on the internet. But yeah, let's look at some of these observations from slide 1. So the length on the right is 12 times the length on the left. They are the same length. Ooh, did anyone else notice that? That 1 foot, right? If we look at our labels, 1 foot, 12 inches. So they are actually the same lengths. It goes up by 12 per foot, goes up 2. Ooh, we make a jump right here. Got to be careful because this table doesn't just climb by ones. Goes up by 12 per foot. You can times the length by 12 and get the answer. All inches are even. 1 foot equals 12 inches. Love it. You can divide the inches in length. Each length is made up of 12. We did this yesterday with dividing. I love that connection. So what, like, okay, so we're looking at this table, right? Can anyone tell me what you notice that this table is, and maybe use one of our vocab words? This table, Lakin. Why? Well, say it louder also. Lakin is saying this table is proportional because all of these numbers, all of these relationships are doing what across here? So what else? So we can say 12 is our constant of proportionality. Okay, my ghost Dave. Because we named the ghost Dave, by the way. When my smart word doesn't work right, I blame a ghost and another class. I'm guessing it wasn't you guys. Another class said we needed to name the ghost Dave. And Dave is actually my best friend's name, so it's funny when I yell at Dave for my smart word not working. So, reminder. You can always find a constant proportionality by taking a y divided by an x. And again, if we do that, it comes out to be 12 here, meaning our constant of proportionality is 12 for that first table. Go ahead and keep going. You guys are awesome. You're learning exactly what you're supposed to learn. Keep going. Hey guys, when spell check or whatever underlines one of your words and tells you it's misspelled, I'm not grading you on spelling, but we should care if we're misspelling words. So please pay attention to like the squiggly underline and maybe click on it and see what suggestions it gives you so we can get better at spelling and what words we might use. Or like instead of using the word timesing, we could use the word multiply. Right? We could use that word multiply instead of timesing, because that's not really, I'm not even sure if that's technically a word. Good looking robot. So now we're going this way. What were we doing going that way? Go to 3 and 12 because they're smaller. How does 3 turn into 12? There it is. So how do we come this way? Boom! Shakalaka. None of you have probably played NBA Jam. Probably not even this is special. Wait, on what console? Yeah. For real? It still exists? Yeah, but before you're on fire. He's heating up.
What happened?
Have you ever played NBA Jam?
No.
It's a basketball game, and if you get if you make 3 shots in a row, you end up on fire, and actually then it's almost easier to make the shots. All right, on slide 2, we meet our robot. Who can tell me what you noticed when we met our... That's what's wrong. My screen is zoomed in. Who can tell me what you noticed? I will take a volunteer if you would like to volunteer. We can change the number of arms. Did anyone notice anything from this slide aside from we can change the number of arms? Josh? Ooh, if we look at these as being our fingers... There are 4 fingers that pop up every time we add another arm. So then, now and all of you are past this. So then they gave us a table telling us about 8 arms having 32 fingers. And then we start filling in some values here. And most of us filled in with pretty much the same values. Anyone want to talk to me about how you figured out those values? Like if I'm trying to catch up here. And I got 7 arms. I should really probably pull out some random cards. Caroline, what can you tell me about, if I'm trying to fill in that table for 7 arms? Yeah, what number would I put there for 7 arms, and how do I figure it out? Sorry, what? Ooh, so Caroline's noticing I'm going 8 to 32. That's a times 4. So if that stays true, what's 7 times 4? 28? So I think we all filled in 28 fingers there. Go ahead and keep going. I just wanted to make sure we all understood what we had done. Go ahead and keep going. Ooh, most of us are already painting robots. You guys are rolling. I might not need to pull us together much. I mean, if they know what they're doing, it makes me feel good. It securely keeps breaking. I'm getting so frustrated. I was trying not to.
I used it yesterday, and I did that. I did the block plan that Shawnee asked about or whatever.
Be aware I'm recording, just as we talk trash about securely.
Well, I was just trying to say that, when I did that and then I used it, I think somebody was using YouTube for school or something, and then it made them get off of it. And I wasn't trying to do that, so I was like, oh crap, I messed them up. Wow.
Yeah, it does not work.
Yeah, there's a lot of great uses in that. Do you need help, Elias? Because I didn't get any. Okay. So let's 6 robots and 2 pounds. We need 6 robots and 2 pounds. How long?
Yeah, you see 11 robots. Oh.
Try it.
You Rocco.
Whoa! I'm gonna be 30 seconds. Most of you are farther than I am, but I need some help because I'm trying to catch up with where you're at. Owen, here they tell us 8 arms, 32 fingers, 7 arms, but then they tell us how many fingers. And then they say we got 44 fingers. What do I do with this? 11 arms. Owen.
So for every arm, there's 4 fingers. So
For every arm, there were 4 fingers.
if you do, so 10 arms is 40, right? 40
Sure, I mean, it's not on the table, but sure.
10 times 4 is 40. If you add 4 more fingers, that's 11 hands.
Yeah, so Jimmy, how'd you think it through?
See, it just came to me because I just literally used the calculator and put 4
Okay, Elijah.
I just think like doing just to kind of count over it was 10 times that, and then it's 40.
Okay.
So you're just gonna add 4 more, it's 11.
Agreed. So we all keep talking about the 10 and the 40. Josh, you're dancing back there. Tell us what you got.
Oh yes, you told me this.
No, I asked you. I did not tell you.
You asked me because if we are multiplying the arms to go to fingers, then if we're going to fingers to arms, that means we're dividing by 4.
Hey guys, here's where I actually have something new to teach you. Sort of new. You've already figured this out, but you are absolutely right. We can just say we're going the other direction. We can divide instead of multiplying. Or, here's where I'd like you to look up here. You can also think of this as multiplication, but instead of multiplying by 4, since we're going the other way, do you know what we would multiply by? 1/4. You use the reciprocal, because this 4 is actually 4 over 1, right? If I write it as a fraction. If I'm going the other way, I can either divide, or we can multiply by the reciprocal. Do you hear that noise? Because I do, and so does everyone else. It's annoying. Please stop doing that. I'm in the middle of talking and teaching, and you're just going to make noises? Pretty disrespectful. Keep going. Like, I don't get it. Even if I'm bored. Come on, that's not appropriate. I'm trying to teach. They're making my job harder. Now we're painting robots. Liam, you skipped slide 4 too. Get your butt back to slide 4. The one I was just talking about. You skipped it. Maybe it's because you're so busy making noise with your shoes.
Oh, yeah, I'm there on slide 8.
I don't care. Go back to slide 4. I did. Ooh, too much pain. So what relationship do we see? Hold on, what relationship do we see here?
Okay, 3.66. There's like a bunch of
Are we getting bigger or smaller? So are we multiplying or dividing? Sure. What do we divide 6 by to get to 2? When we test things out, we need, or you can ask yourself the question backwards. How can we get 2 to turn into 6? So that's a 3 right across here, whether we're multiplying or dividing, whichever way we're going. So if we have 11 robots who are coming this direction, would you multiply by 3 or divide by 3? So we need to take 11 divided by 3. And here's the cool thing. You don't have to use the decimal. Type in 11 divided by 3. Literally type in 11/3. Yeah, you don't have to use the decimal. Fractions are better. Perfect amount of paint now. Look at that. Fractions are better. Major, you doing okay here? 'Cause I'm waiting on you. You're just chatting with Liam or what? So do you want to determine the number of arms or do you want to determine the number of fingers? That's our first question. So then I can determine the number of, so this one is you're trying to determine the number of, wait, if we know the number of arms, how can we determine the number of fingers? So I can determine the number of, by doing what? And doing what? By? What number? Don't type it. Because you told it to me, you don't need to type it. I need more help. I know. I'm really needy. I'm sorry, guys. Ask my wife. I'm super needy. So, Elijah. Actually, no. You called on yourself. Tommy. I'm painting robots now. They tell me I need 2 gallons of paint for 6 robots. You know, it's so there's not just 6 robots though. We're in a factory. Lots and lots of robots. Now they tell me 11 robots. How are you going to figure out the amount of paint we need for 11 robots? How'd you figure that out?
So I looked at 6 and I looked at 2 and then 2 goes into 6 3 times. So I just kind of did that.
And we check it and say, does the same, well, we then did it, right? We were typing these things in. So 11 divided by 3, but when you did that on your calculator, was the number nice? Hey guys, this is where I'd love for you all to look up for like 10 seconds. When you type 11 divided by 3 into your calculator, you get a number that is not nice. It's also not correct. It rounds at the end, and technically it's not absolutely correct. And in con, some of you are getting frustrated, and I think we noticed this yesterday, like maybe it was the other class, we had to type in an exact number of those repeating numbers. You don't have to do that. Fractions are better. And I did not used to think this. When I was your age, I was like, decimals. Money's in decimals. Like, I thought decimals were better. But here, instead of trying to type in that decimal number, you could just type 11 divided by 3, and then it will pop up with equals whatever. Khan Academy does the same. You can type in your fraction value. If you do the division and it's not a nice number and you'd rather type in the fraction, this is actually more accurate. What's the decimal that you end up getting here?
6.
So it's, ooh, 3.66, and eventually your calculator puts a 7 out here. That's not true. If we're okay with rounding, that's true. But that's not technically true.
How long does it keep going?
Depends on how big your calculator is. Like, that division keeps going forever. It literally never stops, because if you do the long division, you keep getting a remainder, and it's the same remainder. And this is also why long division is, you know, it's okay, but it's not good. My wife would say it's fine. Long division's fine. It means it's not great, right? If I'm like, hey, you want to go to like Taco Bell? I know that much doesn't mean. Yes. You did? Oh, so you were testing things? Let's make sure we know how to do the math. I love that it worked out, but let's make sure that we don't just like try it and change it when it's wrong.
It just keeps going.
So the time for painting looks like it's double the amount of paint. So wait, which one's the last one? Because we're going to go over this here in a minute. So this number is smaller than that. Right? If we went this direction, because we want to get bigger, we're allowed to go whatever direction we want. What? Get us from 2 to 5. You can check. Well, you have calculators. So what is 5 divided by 2? Because then you can figure out what it's multiplying by. Okay, so I think we're going to use that number.
Maybe it's 6. 12 divided by 13. Five divided by, or 2 divided by 5 is 3.5. Or 2 divided by 5 is 0.
Six of you didn't even notice what I just did. But I'm trying to give you the last 5 minutes to work on con if you want to. We've got 9 minutes right now, so give me 4, please. Right? 9 minus 5 is 4. So we should all be looking at this slide now. Even if you hadn't quite made it here yet. Because we're just going to wrap up our lesson and make sure we understand these proportions. So, like, random cards are going to help a lot of you guys. So, Elias, can you tell me one thing that you noticed from this table? And there's a lot you can choose to notice. Can you tell me, I'll ask a better question. That wasn't a very good question. Can you tell me how we get from there to there? Yeah, thank you very much. So could you tell me what this number should be? Yeah. Any questions on how Elias got 4 there? Okay, so then, Jackson, can you notice something else or tell me something else to fill in here?
The amount of paint for 15 is 6.
The amount of paint for 15. How'd you get that? Because we got to know how we get it. Because remember I told you guys we can't just be guessing and adjusting when it tells us that we're wrong.
Because the amount of, I noticed that the amount of paint, like the gallons,
Yeah.
is 2 times less than the painting time.
Ooh, so going from here back this way would be divide by 2, since this way was times 2. So Jackson is saying if I do that same thing here, divide by 2, we can get a 6 here. Questions on how Jackson got that 6?
I don't have to do this whole thing. I just
What
figured,
deck of cards?
I just figured the whole thing out.
Major, can you tell me something else to fill in? We've noticed this is times 2, this is divide by 2. I'm not quite sure what's happening here. If you're not quite sure, you're welcome to pass. Like, guys, remember, you can always pass. I'm trying to keep this as a space where you feel comfortable. Yeah, totally fine. And you just go back in the deck. Liam, can you help me? No? So, pass? Okay. Lakin? Reese? We talked about this. You guys figured this out. I know you know it. Yeah. If you don't know how to help me with this table, you need to be paying attention to how Reese is going to help us. So sorry for those of you that are mad that I just paused your computer, but listen to Reese. Here? How'd you figure that out? So this relationship, well actually I need to switch my arrow if you're talking about times 2.5. This going this way, right, is times 2.5. And if we don't know that, is that appropriate during our class? Do you know exactly what you're doing here? You know everything. Okay, good. Do you think everyone in the class does? So is it respectful of them learning to just be sitting there making noises? Guys, and I'm not just talking to Elijah. Many of you have this issue, and I know it's early in the morning, you're all squirrely and full of energy. you need to calibrate to being at school. You need to remember what's appropriate and not. Because this, right now, is a waste of time. Reese figured that out by doing 5 divided by 2 because she didn't know exactly what to multiply by. Jackson, stop what you're doing. So, if we want to go this way, we can do the same thing. You accidentally divided, and that's how you got 2.5. But if we take 5 times 2.5, what's 5 times 2? 10. Now add another half of 5. 12.5. What about down here? To go this way, we said we're timesing there. I'm saying timesing. Timesing by 2 point. What's this become? Anyone? And then what did we do to go this way? Times 2. So this would be 2 now. I know. Geez, Dave. You have the last 4 minutes, because we had to waste a minute. You have the last 4 minutes to do what you need to do. If that's switch over to Khan Academy to answer a couple questions, that is fine. Together, you're always really appreciative of when thanking me and everything. The best thank you that you can give me, I hate it appropriately class, so I don't have to yesterday. Does that make sense? That's the best. You can get a couple questions answered with this time that we have right now. You could switch over to Khan if you want to. We still got 3 minutes. So you want to get a job in a robot factory when you grow up? Although by the time you grow up, it'll probably be robots doing the work in the robot factory.
Oh yeah,
The robots will build more robots.
I don't like that. That's scary.
Nice. If somebody had guided me, love it. If somebody had guided me towards engineering, I maybe would have gone that way.
I like to speak. And one of my friends, he used my
That's sweet. Oh my gosh. See, you guys are growing up with such cool technology to play with.
Oh yeah, my dad grew up with it.
I know I can use it, but when I was 12, none of this existed. Like not even Chromebooks.
Computers were really good.
I mean, yeah, they were big. Like there weren't nobody had
They were
laptops.
huge
Like
and
unless
thick.
you worked at a company when they bought you one, they were very expensive.
They were like this.
I mean,
They were big.
no, like when I was a kid, computers were the towers, right? Like bigger than what we have out in the family room, but similar to a separate tower, cords going to the monitor. Just different.
At least it actually has a computer capability.
And I highly doubt they have labs. Okay, also, I come from Coshocton, which is like more country, like farming and stuff like that. We didn't have a lot of money, right? Like our school district. So maybe some schools had laptops. We were lucky to have a computer lab where we would all go, are you sure she meant laptop? Oh, like the Macs? Yeah, yeah. It all depended if you were Mac or PC. All right, that is all the time we have for today. Have a wonderful day. Hey, Lakin, who are you emailing back and forth with? You know who that person is, right? Okay, just checking because yeah.